Finally, we'll get to see a concept, an idea that will include all the things that we have learned till now. It's known as velocity selector. So the need of this, let me talk about it. In many experiments involving moving charges, it is important that the particle all move with essentially the same velocity. Right? How do you obtain this? Okay, we need it, but how do you obtain it? The heading tells velocity selector, we are selecting a charge with a particular velocity. This can be achieved with the help of combination of electrical field and magnetic field. Oriented as shown. So here we have the positive charges, negative charges. The very first thing that you can notice is the electrical field lines. Perpendicular to that, right, going in is your magnetic field. So they are making an angle of 90 degree with each other. This is the source of the charge, whatever we want to select. So we are trying to see to that they almost go straight. Now, because of the push and the pull by the magnetic field and the electrical field, the one which has the right amount of velocity will go through. If they don't have, then from this point onwards, they'll start either going up or going down. So why is that they'll go up? Why is that they'll go down? Why is that this is going straight? And how is that a particular velocity only will go straight? That's what we're trying to understand. So basically a velocity selector, as the name tells, is going to select a charge with a particular velocity. It uses perpendicular electrical and magnetic field to filter particles based on their velocity. That's the job of a velocity selector. So we're combining both the concepts now. So let's see the actual math. So what do we have? We have this diagram that we can do it in an exam. So this is not for exam. This is the exam oriented diagram. Keeping it simple so that you can do it quickly in your exam. Okay, I think this is good enough. So we have positive and negative charges, and you can, I think one more magnetic field line will be, electrical field line will be helpful. Okay, now it looks okay. So we have a source of charge, we have a slit, and we have the particle going from one end to another end. Okay, just this with a particular velocity. Now, how does this work? Right? So we have a uniform electrical field is directed vertically downwards, and a uniform magnetic field is applied in the direction perpendicular to the electrical field. In this case, it is into the paper. So let's look at the force on the particle. So what and all the force that is the particle is experiencing. So it's going to experience two forces. The first is your, say, magnetic force. I'm going to draw the free body diagram. So you need not do so for your exams. This is only for understanding. I think I'll do it here. Now we have the velocity this way. Magnetic field is inward, right? This is your velocity. This is B in. So as per your right hand palm rule, so we'll have it upward. So this, because of this, the charge will move upward. Force because of P. Okay, and this is given by Q V cross B. The second force that we'll experience is because of magnetic field, electrical field. Electric field or electric force. Let me use the same set of words. Next is free body diagram. So here we have the force downwards actually. Let me do it here. Right? This is a positive charge. Considering this is a positive charge, this would be the force by the electrical field. Simple. Because the electrical field lines are moving from top to bottom. So this being a positive charge will experience a push downward. Of course, we can use the same concept on negative charge also. Then here we have to alter a few things. So let me not do that. Let me consider this to be a positive charge. We have a force that is upwards. We have a force downwards. Now use your common sense. See, this is the education. What I mean is, you guys have to figure out how can I use this setup and select a particle with a particular velocity. Think. How can I make use of this? Simple. Condition for no deflection is the following. We have a particle experiencing two forces, right? So one is upwards, one is downwards. One is because of, doesn't matter, whatever the cause may be, right? How can I make it not go up or down? Yes, these two have to be same. As simple as that. The magnitudes have to be same. For a particle to pass through the selector without deflection, the electrical magnetic field force must be equal in magnitude and opposite in direction. You guys agree? If something is more, it will either go up or down. As simple as that. Right? So basically, therefore, the magnitudes have to be same. So we can equate that. So this expression is Q VB is equal to QE. Okay. Now, since we are not looking at only the magnitude part, so this is a, I need to write this only. Yeah. So as V and B are perpendicular, this implies theta is equal to 90 degree. This is QVB sine 90 degree. So sine 1 is equal to QE. So Q and Q will get cancelled. So a particle with the ratio of E by Q, right? Yeah. E by, not Q, sorry, E by B will be able to go through. So adjust E, adjust B, and we get to select a particle with a particular velocity. So conclusion. Of course, every formula, every derivation, we need to conclude by varying E and B. So basically varying the potential and varying the magnetic strength, we can select a particle with a particular velocity. Agree? That's it. As simple as that. Right, guys? A very simple concept using up all the things that we have learned till now.